The Nartest NTX 2000 is a drug analyzer that identifies the presence of marijuana, cocaine, heroin, methamphetamine, ecstasy, amphetamine, and two precursors for methamphetamine production in C-street samples. The analyzer uses spectral fluorescence signature technology, or SFS. SFS technology is a revolutionary application of fluorescence spectroscopy in combination with image recognition based on a neural net learning tool. This technology examines how a sample fluoresces in the presence of light and offers a three-dimensional record of the sample's fluorescent spectrum. This spectrum is interpolated into a digital image and then analyzed based on an extensive database that contains images of known compounds and mixtures thereof. What is SFS? It all starts with light. When light is shown into a substance, it may cause its molecules to change to an excited state and then relax back to their original state. When the molecules relax, they emit light. Fluorescence spectroscopy is the study of the light that is emitted from a substance as it returns to its relaxed state. It is important to note that when two different substances are illuminated with the same excitation light, you can receive a different fluorescence response. When this was first observed, fluorescence was used as a way to differentiate substances that otherwise were not easily distinguished. For this reason, fluorescence has long been used in forensic drug analysis in order to distinguish different types of drugs. Traditionally, light was filtered so that one specific wavelength of that light is focused into a sample. This is called excitation. As the molecules are exposed to the excitation light, they emit different wavelengths of light. The resulting emitted light and the intensity of each wavelength is measured by a light sensor and then recorded as a line graph with emission wavelength versus intensity. The NTX 2000 significantly improves on traditional fluorescence spectroscopy because it records emission light at not just one wavelength of excitation, but many, recording a series of fluorescent spectra for the same substance. Instead of just collecting a series of these two-dimensional fluorescent spectra, the NTX 2000 also measures the intensity at each wavelength pair, creating a third dimension. Each level of intensity is assigned a color and a three-dimensional topography is created. The result is a three-dimensional fluorescent spectrum for that particular sample. The 3D spectrum is then interpolated into a data graph image containing 1,620 points that show the substance's unique reaction to excitation light, its unique signature. This signature provides a result that can be used to distinguish a particular component in a complex mixture. This was not possible with traditional one-line fluorescence data. Now that the NTX 2000 has measured and recorded the SFS of the sample, it must analyze it. How? Pattern recognition. Pattern recognition is a powerful technique commonly used in modern forensic science. It is utilized every day to link evidence from unknown origins to their original source. For example, fingerprint analysis has used pattern recognition since 1892 to identify a unique fingerprint as having been made by one specific individual. In 1970, advances in computing enabled the ability to electronically store, analyze, and retrieve fingerprint records efficiently. Now, latent print examiners internationally use AFIS, Automated Fingerprint Identification System, to match fingerprints, while at the same time ruling out millions of other candidates. AFIS solely depends on the technique of pattern recognition to identify unique points and features in a fingerprint. In similar fashion, ballistics, the science of firearms and projectiles, utilizes pattern recognition in the analysis of unique markings that occur when a bullet is fired from a gun. An internationally developed database of bullets has been compiled and is used frequently to identify bullets that have been collected at crime scenes. And more recently, the Combined DNA Index System, or CODIS, is a national database developed by the FBI which uses pattern recognition to match DNA profiles from unknown samples to the DNA profiles of convicted felons. In all three of these methods, question samples are compared using pattern recognition to a database collection of stored patterns to efficiently and accurately provide foolproof evidence of their origin. By combining pattern recognition and the unique SFS signature of a substance, The NTX 2000 is able to analyze drug samples efficiently and effectively. Similar to fingerprints, a unique pattern can be recognized and recorded in a database. However, where a conclusive fingerprint identification may be based on 6 to 50 points, the SFS data provides over 1,600 points for comparative analysis, ensuring an accurate identification. By thoroughly analyzing controlled substances, their diluents, and other substances common to the drug world, NarTest has built a comprehensive database of spectral fluorescent signatures that are used to train the neural net. This internal neural net learning tool uses statistical pattern recognition known as spectral fluorescence image recognition to analyze the 1,620-point signature of an unknown sample and report a result either identifying or eliminating the presence of a specific drug. Now that we know how the drug analyzer works, let's take a look at the testing process. A blank is run on the drug analyzer to ensure that the solvent and supplies that are going to be used to handle the unknown sample are clean and free of any contamination. The sample cell has a clear optical window that allows for the direct application of light. The sample is prepared and placed into the sample cell. As this data is measured and collected, the resulting 3D spectral fluorescent signature is produced on the screen for the operator. This signature is then converted to a spectral fluorescence image so that it can be analyzed by the software's neural net. A conclusion as to whether the presence of the particular drug of interest is identified or eliminated is then displayed on the monitor and saved into a secure data file. All results are recorded into a report that the user may print for their records. The information contained in these reports is secure and may not be changed or edited. While the science being utilized by the NTX 2000 is complex, operating it is fast and easy. All users are trained and certified prior to initiating use of the NTX 2000. The software walks the user through a specific step-by-step process. It includes built-in verification of prior steps before allowing the user to continue to the next step. The NarTest NTX 2000 drug analyzer is being utilized internationally to identify widely used drugs of abuse. Rigorous validation testing has verified that an exhaustive database in combination with its learning neural net make the NarTest NTX 2000 accurate and dependable. We can now add drug analysis to the list of forensic applications currently utilizing pattern or image recognition to help identify an unknown.